Hi, welcome to this video. We're going to cover how we can build a tokenizer for Bert from scratch. So typically when we're using transform models, we have three main components. So we have the tokenizer, which is obviously what we're going to cover here. We have the core model, and we also have a head. So the tokenizer is obviously what converts our text into tokens that Bert can read. The core model is Bert itself. So Bert has kind of like a core, which we build or train through pre-training. And then there's also a head, which allows us to do specialized tasks. So we have like a Q&A head or a classification head and so on. Now, a lot of the time, what we can do is just head over to the HuggingFace website over here, and we can say, okay, we have all these tasks over here. If I want a model for question answering, I can click on here. And typically there's usually something we can use. But obviously it depends on your use case, your language, and a lot of different things. So if we find that there isn't really a model that suits what we need, or it doesn't perform well on our own data, that's where we would start considering, okay, do we need to build our own transformer? So in that case, at the very least, we're probably going to need to build or train from scratch a core model and the tokenizer or transformer head. So we definitely need those two parts. And sometimes we'll find that we also need tokenizer as well, but not always, because you think, okay, we already have tokenizers for, say, our task is something to do in the English language, but the model doesn't perform very well in our specific data set. It doesn't mean that it hasn't been tokenized properly. It can still tokenize all that text probably pretty well, as long as it's like standard English. But what we'll find is that the model just doesn't quite understand the style of language being used. So, for example, if Bert is trained on blogs on the internet, it's probably not going to do as well on governmental or financial reports. So that's the sort of area where you think, okay, we're probably going to need to retrain the core model so it can better understand the style of language used in there. And then the head is, like I said before, that's where we are training it specifically for a specific use case. So for Q&A, we'd probably want to train our model on a specific question answering data set, so that it can start answering our questions. Now, in that case, and it's in English, we probably don't need a tokenizer, but sometimes we do need a tokenizer because maybe your use case is in a less common language. And in that case, you probably will need to build your own tokenizer for Bert. And that's really the sort of use case that we would be looking at in this video. So we'll cover that, building a WordPiece tokenizer, which is a tokenizer used by Bert. And we'll also have a look at how we can get, or where we can get, good multilingual data sets from as well. So let's move on to what the Bert tokenizer is and what it does. Okay, so like I said before, the Bert tokenizer, it's called a WordPiece tokenizer. So this text up here, WordPiece, and it's pretty straightforward. What it does is it breaks your words into chunks or pieces of words, hence WordPiece. So, for example, the word surf is just probably most likely going to return a single token, which would be surf, whereas the word surfing, the ing at the end of surf is a pretty common part of a word, in English at least. So what we would find is this word here would probably get broken out into these two tokens. Now, where we see this prefix, the double hashtag, that's the standard prefix used to indicate that this is a piece of a word rather than a word itself. And then we see that further down as well. So surfboarding gets broken into 3 tokens. And then if we, for example, compare that to snowboarding and surfboarding are obviously kind of similar because they are both boarding sports. The difference being one is on surf, the other one is on snow. And before we even feed these tokens into Bert, we're making that very easy for Bert to identify where the similarities are between those two objects, because Bert knows that, okay, one of them is surf, one of them is snow, but both of them are boarding. So this is helping Bert from the start, which is, I think, pretty cool. Now, when we're training a tokenizer, we need a lot of text data. So, well, when I say a lot, let's say 2 million paragraphs is probably a good starting point, although ideally you want as much as you can. So what we will use for training our data is something called the Oscar dataset, or Oscar corpus. Now, Oscar is just a huge multilingual dataset that contains just an insane amount of unstructured text. So it's very, very good, and we can access it through HuggingFace, which is super useful. So over in our code, first, if we want to download datasets, we need to pip install something called Dataset. So pip install datasets. I already have it installed, so I'm just going to go from datasets, import load dataset. Okay, and then through that, we can use the datasets.list datasets method. Let me import datasets as well. Import datasets. Okay, and this will give us a very big list, probably a little bit too big, showing us all the datasets that are currently available in the datasets library, which is quite a lot. I think it's like 1,000, just a fair bit over 1,000 now. Okay, so we have all of these, which is a lot. I wonder how many. Let me length datasets list datasets. My internet is very bad at the moment, so it takes forever to download anything. But there are datasets, and this is one way of viewing those datasets. But an easier way, this is how many we have in all of HuggingFace, and there's new ones being added like every day. So, but an easier way of doing this is to go to Google, type in Datasets Viewer or HuggingFace Datasets Viewer, and just click on a Streamlit HuggingFace. So this is a Streamlit app HuggingFace have built that allow you to sort of go through their datasets. So you see over here, we go over to datasets, and I'm going to type in Oscar because that's the one we'll be using. Oscar. Okay, I type Oscar, and then on the right, it should pop up. So within Oscar, we have all these different datasets. So the first one here is Africans, the language, and then you have all these other ones down here. I'm going to be using Italian as my example here, but Italian has a lot of data. So if I click on here, it doesn't actually show you anything, which is a little bit annoying, but it's because it's just a huge data set. It can't show you everything. So in fact, so that is 101 gigabytes, 102 gigabytes of data there. So it's a lot, but that's good for us because we need a lot of data for training. So if we want to download that data set, we need to do this. So we write datasets or dataset, and it's just a variable name. And we want to write load dataset. And then in here, we need to write the dataset name. So it's Oscar. And then we need to specify which part of the dataset it is. So over here, it's a subset. It's unshuffled, deduplicated, it. If I can't select it, so never mind. So deduplicated, it, and it's also unshuffled, deduplicated, it. Is that right? Looks good. And then the other thing that we can do is we can write split, and we can specify how much of the data we'd like. Now, when you use this split, it's still going to download the full data set to your machine, which is a little bit annoying, but it's just how it works. So I found that this isn't particularly useful unless you're just loading it from your machine and you're saying, okay, I only want a certain amount of data. What you can do, so this is 101 gigabytes. It's a lot. If you don't want to download all of that, you can write streaming equals true, And this is very useful. So what this will do is create an iterator, and you can iterate through this object and download your data or samples one at a time. Now, because I already have my data downloaded onto my machine, I'm going to use the split method. So I am going to take the first, I'm going to say 500,000 items, simply because, I mean, obviously you want to be using more samples than this, but I'm just going to use this many because otherwise the loading times on all of this is pretty long. I don't want to be waiting for too long. And we also need to specify which data set or subset we're using here. So typically we have either train, validation, or test in our data sets. I think we always have the train set in there, and then we can have validation and test sets as well. So we'll load that. And then what I'm going to do is I'm going to create a new directory where I'm going to store all of these text files. So when we're training the tokenizer, it expects plain text files where each sample is separated by a new line. So I'm going to go ahead and create that data set for us. So I'm going to make directory. I'm going to call this Oscar. And then what I'm going to do is loop through our data here and convert them into the file format that we need. So first thing I want to do is import tqdm auto import tqdm. So and I'm using this so that we have a progress bar so we can see where we are in that process, because this can take a while. So I'm going to create this text data list. So we'll populate this with all of our text, and I'm going to use this file count, set that to 0. So this is just going to loop through, and we're going to create all of our text files using this here. So what I want to do is for sample in tqdm dataset, yes. For now, I'm just going to pass. Okay, and let's run that, and we see that we get this bar, this tqdm bar. You see, we're not even doing anything at the moment, and it's already taking a long time to process the data. So I'm actually going to I'm going to go down to 50,000. So I'm not waiting too long. So let me modify that 50,000, and that should be a little bit quicker. Okay, that's much better. Now, first thing I want to do is we're going to be splitting each sample by a new line character. So I want to first remove any new line characters that are already within each sample. Otherwise, we're going to be splitting our samples like midway through a sentence. So I want sample equals sample. And in here, so if I can show you a sample. Yeah. We have ID, and then we also have the text. We want the text, obviously. So we just write text. And we want to replace new line characters, if there are any. Hopefully there's not anyway, with a space. And then what we want to do is just append that to our text data. So text data, so append sample. And what we want to do, so we can put all this in a single file, but then that leaves us with one single file, which is huge. So, I mean, for 50,000 samples, it's not really a problem, but we're not going to typically be using that many samples. It's going to be more like 5 million, 50 million, or so on. So what I like to do is just split the data into multiple text files. So what I do is I say if the length of the text data is equal to, let's say, 5,000, at that point, I want you to save the text data and then restart again and start populating a new file. So let's say with open, so we need to open the file. We need to save it into this Oscar directory that we built before. So Oscar, and I'm just going to call it file count .text. So you convert this into an F string, I'm not sure why it's highlighting everything here. And we are writing that file. So with that, that's why we want to do fp.write, and then we just write our text data. Write our text data, but we also, so this is a list, and what we want to do is we want to join every item in that list, separated by a new line character. So we write this, and that creates our files. Now, at this point, we've created a file and our text data still has 5,000 items in it, and we're going to start looping through and populating it with even more items. So what we need to do now is or initialize or empty our text data variable. So that's empty again. It can start counting from 0 all the way up to 5,000 again. Okay. And so at this point, we're saving our file. So this will initially be file underscore 0.text. But if we loop through again and do it again, it's still going to be 0. So we need to make sure we are increasing that file count so that it's not remaining the same, just overwriting the same file over and over again. Okay. And what you can also do if you want is you can add another. So this down here with open, you can add that just in case there's any leftover items at the end there that haven't been saved into this neat 5,000 chunk. I'm not going to do that now, but you can add that in if you want to. Okay, so it looks pretty good. The only thing that we do need here is actually we need to make sure the encoding is UTF-8. Otherwise, we'll get, I think we'll get an error if we miss that. Okay, so that will or should create all of our data. So let me open that directory here on the left. So we have this empty Oscar directory. I'm going to run this and we should see it get populated. So it's pretty quick. There we go. So we're building all these plain text files here. And if we open that, ignore that, and we see that we get all of these. So each row here is a new sample. Okay, and as you can see, it's all Italian. So that's our data. It's ready. And what we can do is move on to actually training the tokenizer. So the first thing we actually need to do is get a list of all those files that we can pass on to our tokenizer. So to do that, we'll use the pathlib library. So from pathlib, import path. And we just go string x for x in path. So here we need to specify the directory where our files will be found. So that is just Oscar. And then at the end here, we just add this glob. And here in this case, we don't need to do this because if we just use path, here it will just select all of the files in that directory. And in our case, we can actually do that because there's no other files other than the text files. But it's good practice to just, in case there is anything else in there, we can use this function here to say within this directory, just select all text files. Okay, and then let's have a look. So in paths, we should have all of our files. And let's see how many of those we have. Okay, so we have 10 of those. So in total, 50,000 in total samples there, because we have 5,000 in each file. Okay, so now let's initialize our plain tokenizer. So we want to do from tokenizers. So if you don't have tokenizers installed, super easy. All you have to do is do pip install tokenizers. Again, this is another HuggingFace library like transformers or datasets, which we used before. And from transformers, we want to import the Bert WordPiece Tokenizer, which is showing us there. So we load that, and then our tokenizer, we initialize it with Bert WordPiece Tokenizer again. And then in here we have a few different variables which are useful to understand. So first one is clean text. So this just removes obvious characters that we don't want and converts all white space into spaces. So we can set that to true. We have handle Chinese characters. Now this, I'll leave it as false, but what this does is if it sees a Chinese character in your training data, what it's going to do is just add spaces around that character, which, as far as I know, allows, but at least when we're tokenizing those Chinese characters, it allows them to be better represented, I assume. But I don't know Chinese, and I have never trained anything in Chinese, so I don't know. But that's what it does. Strip accents. So this is a pretty relevant one for us. So this is, say if we have like an E like this, it will convert it into this. Obviously for Romance languages like Italian, those accents are pretty important. So we don't want to strip those. It's also strip, not string. And then the final one, lowercase. So this is if we want to view this is equal to this, we would set lowercase equal to true. In this case, for me, I'm happy to have those capital characters as being equal to lowercase characters. That's completely fine. So that initializes handle Chinese characters like this. So that initializes our tokenizer. Now we train it. So tokenizer.train. In here, we need to first pass our files. So is it pass that we use up here? Yeah, pass. So training it with those. We want to set the vocab size. So this is the number of tokens that we can have within our tokenizer. It can be very small for us because we don't have that much data in there. We want to set the min frequency, which initially I thought, that must mean that, the minimum number of times a token must be found in the data for it to be added to the vocabulary. But it's not. It's actually the minimum number of times that it must see two different tokens or characters together in order for it to consider these as actually a token by themselves, so merged together. So typically I think people use 2 for that, which is fine. Special tokens. So these are the special tokens that are used by Bert. Special underscore tokens. And for that, we will have padding. So the padding token, the unknown token, the classifier token, which we put at the start of every sequence. Let me put this on a new line. We have the separator token, which we put at the end of a sequence. And then we also have the mask token, which is pretty important if we are training that core model. We also have limit the alphabet. So this is the number of different characters that we can see within our vocab. So limit alphabet. So we'll go with 1000. And the WordPiece is prefix. So this is what we saw before in the example where we had the two hashes. And this, like I said, it just indicates a piece of a word rather than a full word. And that should be it, actually. So I don't think there's really anything else that is important for us. So we'll train that, make sure hopefully it will work. Again, this can take a little. Well, this will take a little bit of time, even with our smaller data set. So let's see what it's showing us. It's not. I don't know why. I think I need to install something here because I just get this blank output. I think it's supposed to be a loading bar. And then what we do at this point is we probably want to save our new tokenizer. So I'm going to save it as new tokenizer. And I just write tokenizer.save model. And that is going to go to the new tokenizer directory. So new tokenizer. Okay. And that will save this vocab.txt file. And if we just have a quick look at what that has inside. So we come over here. We have new tokenizer, vocab.text. And then in here we can see all of our tokens. Okay, so the way that this works, so you can actually see, you know how we use that alphabet, the limit alphabet. We can see that there are 1,000 tokens. So this stops at 1005 and then go all the way up here. So it begins at row 6. So that's the 1,000 alphabet characters, so single characters that are within or allowed within our tokenizer. Now, the Oscar dataset is just pulled from the internet, so you do get a lot of random stuff in there. So we have a lot of Chinese characters when we're dealing with Italian, but if we come down here, we start to see some of those Italian words. And these are the tokens. So our text, our tokenizer, is going to read our text. It's going to split it out into these tokens. So like the ABB, OP, FIN. It's going to split out into those. And then the next step is to convert those into token IDs, which are represented by the row numbers of those tokens. So if it saw FIN in the text, it would replace that with the FIN token. And then it would replace the FIN token with this 2201. Now let's see how that works. So first thing is, well, how do we load that tokenizer? We do it as we normally would. So from transformers, import, we're using a Bert tokenizer. So import Bert tokenizer. And we'll say tokenizer equals Bert tokenizer from pre-trained. And all we do is we point that to where we saved it. So it's a new tokenizer. And that should load. Okay, so first I want to say tokenizer, and I'm going to tokenize ciao, come va. And this is just, hi, how are you? And we see that we get these tokens here. So we have number 2 here, which if you probably don't remember, but in our text file at the top, we had our special tokens. Row number 2, we had the CLS token, so the classified token, which we always put at the start of a sequence. And then at the end, we also have this 3, which is the separator token. Now, if we just go and open that vocab file that we built, so it's new tokenizer, vocab.text. If we read that in, so let's write vocab fp.read, and we want to split by new line characters. So split like so, because every token is separated by a new line. We can see, let's have a look at the special tokens. So we have padding, unknown, CLS at position number 2, and separator at position number 3. So if I were to go number 2, we'd get CLS, which aligns to what we have here. So what we can do is we could take all of these values and we could use them to identify from this vocab. And we can do it using Tokenizer decode, by the way, as well. But I'm going to do it by indexing in that vocab file that we built, just to show that that's what the vocab file actually is. That's how it's used. So if I write that out, so we have, take this, I want to access input IDs. Okay, and what I'm going to do is say for I in that list, can you print vocab I? And at the end, we'll add a space. Okay, and then we get this. So CLS, the starting classifier token, ciao, exclamation mark, come va, question mark, separator token, which marks the end of our sentence, which I think is pretty cool. Now let's try that with something else. So we'll take this again. Do I want? No, okay, so yeah, we'll just do this. So what I say a lot when in Italy is ho capito niente. And ho capito niente means I understood nothing, which is very useful. So if I print that out, we see that we get CLS, ho capito niente, separator. Now what we're seeing here is, full words. We're not seeing any word pieces. So if I can find it, I think this will hopefully return a word piece. So responsibilita, like this. Let me try it. This will hopefully return a few word pieces. Yes, there we go. Okay, so we see respond, si, billy, ta. And these are our different word pieces. So this gets separated into not just a single token, but 4 tokens, which is pretty cool. Now, I mean, that's it for this video. Don't think, yeah, I mean, there's nothing else I think we need to cover. That's pretty much everything we really need to know for building a WordPiece tokenizer for using with Bert. So yeah, thank you very much for watching, and I will see you in the next one. Bye.